Hey, welcome to our lesson today on algebraic fractions. Today, I want to look at how we simplify some pretty involved algebraic fractions, fractions that involve x's and x squareds and things like that. And in order to do that, I think we have to go back and look at how fractions and how reducing or simplifying fractions really works. So let's go back to that elementary school level and let's look at fractions logically. I'd like to revisit fractions and really understand the math involved in reducing or simplifying a fraction. And when I do that, it doesn't matter if I'm working with elementary school kids or calculus kids. I like to teach my fractions through this concept of Mr. 1. Mr. 1, I have two rules for Mr. 1. The rules for Mr. 1. Rule number 1, he can wear any outfit he wants to wear at all. As long as he wears the same on top as he does on the bottom, he has to match perfectly, and he can't wear nothing. So let's pick this apart and really understand what it is I'm saying here. What I'm saying is anytime you see a fraction where you have the exact same number on the top as you do on the bottom, you should recognize that as a 1. 5 over 5 is 1. The exact same number on top as the bottom, that's a 1. Even if that number is a fraction, 1/2 over 1/2, that's a 1. When I say he can't wear nothing, I'm not implying Mr. 1's like a pervert running around wearing nothing. What I'm saying, though, is 0 over 0. Remember in math, 0 is the idea of nothing. That's not 1. As a matter of fact, it's nothing. It's undefined. We have one rule in math that says you can never divide by 0, and there are no exceptions to that. So when you have 0 over 0, it's not 1, it's not 0, it's just undefined. Now, the second rule for Mr. 1 is he's special for multiplication. Mr. 1 really is able to show his superpower anytime multiplication occurs. So if you have 8 and you happen to multiply it by 1, it doesn't change. It stays 8. And that power is special only for 1 when you're multiplying. That's why we call 1 the multiplicative identity. You don't need to know that word, but it basically says whenever you multiply by 1, you don't change the number at all. So anytime you have multiplication, Mr. 1 likes to show up. So let's take a look at how Mr. 1 is used for fractions from like elementary school. In elementary school, you had to simplify or reduce a fraction like 28 over 35. And I think a lot of times in elementary school, teachers would be tempted to use the word cancel, that you cancel numbers. And I don't care for that because I think it makes kids think that numbers are magically disappearing when that's really not what's happening at all. So let's take a look at how we go through this process of simplifying 28 over 35 without using the word cancel, but understanding the logical mathematics behind it. So step 1, it's just a two-step process, is we want to make multiplication occur. Why? Because Mr. 1 loves to show up for multiplication. How do you make multiplication occur? By factoring. So what we're going to do is we're going to factor the numerator, maybe into 4 times 7, and factor the denominator into 5 times 7. Now, you might remember that whenever you multiply fractions, you multiply straight across. So I can pull this numerator and denominator apart and get 4/5 times 7 over 7. Now I know what you're thinking. 7 over 7? That's step 2. Step 2 is look for Mr. 1. And Mr. 1, same on top as it is on the bottom. And now that we have a 1 showing up, let's use his special power. What is any number times 1? Well, it's that number, 4/5. So without using the word canceling, but using instead the phrase making 1, we're able to take this pretty big fraction, this pretty big numbers, and reduce it or simplify it to much smaller numbers. Now, how do we do that with more, let's say, interesting fractions? Well, let's take a look at this. We have here what's known as a rational expression. rational implying ratio or fraction, and it's an expression because it has x's and x squareds. So how do we handle this? Well, we follow the same two steps we would if this was a simple elementary school fraction. First, we make multiplication occur. How? By factoring. So why don't you pause the video, write this rational expression down, and factor it. Well, welcome back. Hopefully you paused the video and you factored the top and you factored the bottom. And when I factored these, this is what I ended up getting. What do you do once you have multiplication? You look for Mr. 1. Now remember, with Mr. 1 wearing the same on top as he does on the bottom. What's he wearing up here on the top? Well, I see the quantity of x plus 4 in the top. And in the bottom, I also see the quantity of x plus 4. Who is that? It's Mr. 1. What's any number times 1? Just that number. That is your final answer. Again, if you understand the logic and the math behind it, you can handle more complicated expressions because you understand what's going on. Now, there always turns out to be a conversation where kids say, look, why can't we cancel those x's? Why can't we make those x's disappear? And that's a fair question, and that's a great question. And let's see if we can understand why that is. So I took this expression, x minus 3 over x plus 2, and I brought it down here, and let's see why you can't cancel those x's. Because I know kids desperately, they want to just cancel those x's away. And let's think about basic fractions. So let's look at the fraction 3/4, which I've modeled here in a measuring cup, and 1/2, which I've modeled here in a measuring cup. First of all, you can tell they're not the same fractions. 3/4 is bigger than 1/2. But let's see what's going on. If you broke apart 3/4 not by factoring, but through addition, you'd get 1 plus 2 over 2 plus 2. And if you were tempted to cancel those 2's, notice I didn't say make 1. I'm not saying make 1 because it's not multiplication. But if you cancel those 2's, you would end up with 1/2. Well, no. Is 3/4 the same as 1/2? Absolutely not. That is just not true. So that's why canceling doesn't work. It's why making 1 works, but it only works if you have multiplication. And these x's are not attached to these two numbers through multiplication. So if it's not multiplication and you can't make multiplication by factoring, you're done. So let's get in and do some practice together. So let's take a look at factoring and simplifying and finding Mr. 1 with some more complicated fractions. So here's one. Why don't you pause the video, try number 1 all by yourself, and then come back and see how you did. Hey, welcome back. Hopefully you did our two-step process. Step number 1, make multiplication occur. Why? Because every time you have multiplication, who likes to show up? Mr. 1. And you see him here wearing the quantity of x plus 2 over the quantity of x plus 2. That's 1. And what happens when you take any number times 1? You get that number. And that's it. That's as far as you can go. I know you're tempted to quote unquote cancel those x's, but it's addition. And Mr. 1 is not special for addition, only multiplication. We are not canceling. We're making 1. Here's another one. Why don't you try number 2, pause the video, see if you can make this work, and then come on back. Hey, welcome back. Hopefully you did our two-step process. Step 1, make multiplication occur by factoring. Step 2, look for 1. Again, this is just coincidence. I see Mr. 1 wearing x plus 2 on the top and the quantity of x plus 2 in the bottom. Any number over itself is 1. Any number times 1, just that number. Let's try a third one. This one's a little bit more involved. So why don't you take a look at number 3 here. Pause the video, see how you do. Now, number 3, I know it looks scary. I know that you've got numbers in front of the x squared, and you're probably like, oh, this is going to be one of those fun problems to factor. But remember our trick. Anytime you go to factor, the first thing you should try to do is look to pull out a GCF. And sure enough, in the numerator, I could pull out a 5. And in the denominator, I could pull out a 10. So I hope you saved yourself the headache of dealing with these big coefficients and you just pulled that GCF, that greatest common factor, out. Now, what do we have left? Well, we've got more factoring to do. In the numerator, we can factor x squared plus 6x plus 9 into the quantity of x plus 3 times the quantity of x plus 3. Don't forget the 5. And in the bottom, not only can we factor x squared minus 9 into the quantity of x plus 3 times the quantity of x minus 3, but we also can factor the 10 into 2 times 5. And now that we have nothing but multiplication as the main operation, we can look for 1. See him wearing the quantity of x plus 3? And you also see him wearing those 5s? So what do we have left? In the top, we have an x plus 3. And in the bottom, whoops, in the bottom, old Mr. Brath, he left out, we have a 2 times the quantity of x minus 3. Don't forget that 2 is right there. Now, if you want, you can distribute that 2, or you can leave it factored out in front. So if you want to call this the quantity of x plus 3 in the top and 2x minus 6 in the bottom, you're welcome to do that, or you can just leave it out in front. It's up to you. Well, I hope this helped. And today we have some practice problems I want you to go through. Make sure you're following our 2-step rule of factoring and then finding 1. Good luck.